Hi students, in this video, let's try to understand quantitative comparison questions. Now, these are very important questions because you will get approximately 7 to 8 quantitative comparison questions per section. Alright, so let's dive deep into these type of questions and build a strong arsenal of techniques which you can use to tackle these type of questions. So in this video, we start with understanding the structure of these type of questions and then we'll move on to techniques to handle these type of questions. Alright, now as the name suggests, quantitative comparison questions are questions where you need to find a relationship between two quantities. Alright, now to understand this question structure, let's take a sample question. So over here, I have a sample question. X is greater than 5, Y is less than 30, X and Y are not equal. Alright, so this part over here is the question stem. Alright, now in quantitative comparison questions, you may or may not have a question stem. Alright, now what's the remaining part? Over here you can see that quantity A is given, which is X by Y for this question. Similarly, over here you can see quantity B is given, which is Y by X in the case of this question. So you will be given two quantities, alright, and then you have 4 answer options out of which you need to choose the right option which rightly describes the relationship between these two quantities. Alright, now as I've already mentioned, you may or may not have a question stem over here. So in some questions, some extra information will be given over here, and in some questions directly quantity A and quantity B will be given to you. Alright, now let's try to understand these 4 options. Option A is quantity A is greater. Alright, so that means if quantity A is greater than quantity B, you need to mark option A. Now remember, this must be so in all cases or for all values, right? It should always be so if this is the right answer. Similarly, if you mark option B, then quantity B has to be greater than A, and it has to be so in all cases and for all values. Alright, now if you are marking answer C as the right answer, this would be correct if the two quantities are always equal. Alright, now we are left with one more option. Now, if the relationship between these two quantities varies, that is, sometimes A is greater than B, sometimes B is greater than A, or sometimes they are equal, right? So there is no constant relationship, it's varying. In this case, you need to mark answer option D as the correct answer. Alright, now remember, in all quantitative comparison questions or QC questions, right, the 4 options will always be the same. Now, don't worry about by-hearting or memorizing these options, because as we dive deeper and solve more and more questions of this type, naturally you will start remembering these 4 options. Alright, now that we have understood the structure of these type of questions, let's try to understand 2 very common approaches to tackle these type of questions, and after this we will get into the techniques. Alright, now 2 very common methods employed to solve QC type questions is plugging in numbers and then employing algebra. Alright, now a very important thing that I would like to highlight to you before we go deeper into these techniques as well as other techniques is that don't rely on just one of these approaches. There are many students who only rely on plugging in numbers, and there are many students who only rely on algebra. But I would strongly recommend that you use both these approaches appropriately. Now that will help you to have sufficient tools to solve any question given to you in the best possible manner. Now remember, plugging in numbers is very useful to prove the answer as option D, that is, the relationship cannot be determined. And algebra is many times very useful in arriving at the correct answer, whether it is A, B or C, in a very short time. Let me quickly demonstrate this to you over here, and then we will move on to the techniques in great depth. Alright, now let's take a sample question. Say it's given that X is less than 4 and Y is less than 3. Alright, so that's the question stem, and quantity A is X and quantity B is Y. Now it is very convenient to plug in numbers and check. Alright, now if I take X as 1 and Y as 2, I find that quantity A is greater than quantity B, right? And this is true, right? If I take X as 1, that's less than 4, so this part over here is true. And if I take Y as 2, then that's less than 3, so this part is true, right? Alright, now what if I take X as 2 and Y as 1? then I get the reverse, right? Quantity A is greater than quantity B. Now, because sometimes I'm getting less than and sometimes I'm getting greater than, the relationship cannot be ascertained, and the correct answer is option D. Alright, now what about algebra? Let me quickly demonstrate to you that it's very useful to know algebra. Alright, so over here I have a sample question. A and B are such that A plus B the whole square is greater than A square plus B square. Now quantity A is A into B and quantity B is 0. Alright. Now we need to find out which of these two quantities is greater, or whether at all we can find the relationship. Now if you employ plugging in numbers to find the relationship, you would have to try different combinations, right? Now because we know the identity of A plus B the whole square, it's very useful to use algebra over here. Now A plus B the whole square is A square plus 2AB plus B square. So as per the information given in the question stem, A square plus 2AB plus B square is greater than A square plus B square. Now I can remove A square plus B square from the left hand side and the right hand side, right? Because you can add or subtract anything in an inequality without changing the sign. Now we cover this in great depth and the reason behind this in the section where we discuss inequalities. Alright, now over here we get 2AB greater than 0, right? That means AB is greater than 0. So clearly I can find that quantity A will be greater than quantity B without trying to have different combinations of numbers. So algebra in this aspect is very useful. So again, let me summarize. Have a mentality that you are ready to employ techniques as well as use algebra. Alright, now let's get into various techniques to help you tackle QC questions in the best possible manner and in the least amount of time. Alright, now the first point that I bring to you is do operations on quantities. What do I mean with that? Let's take a sample question to understand this. So I have two quantities, quantity A that is x minus 9x square minus 12 and quantity B that is 15 plus x minus 9x square. Now when it comes to operations on quantities, you can perform the same operation on quantity A as well as quantity B without changing the relationship between these two quantities. What are the operations that you can do? You can add, you can subtract, you can multiply or divide. But when it comes to multiplication and division, you can do it only with a positive number. Let's try to understand this better. Now we know that if we take two numbers 7 and 9, 7 is less than 9. Now let's perform an addition and check whether the relationship is changing. So I'm adding 2 to 7 and 2 to 9. Now you can see that the relationship is still the same, right? 7 plus 2 is 9 and 9 plus 2 is 11. So over here we have a less than relationship and it is maintained over here, right? Now let's subtract something from 7. Now and from 9, both the sides we need to subtract the same number. If I subtract 3 from both sides, I have 7 minus 3 and 9 minus 3. And you can see that the relationship is still the same, right? 7 minus 3 is 4 and 9 minus 3 is 6. Alright, now what if I divide and multiply by a positive number? So let's do that over here. I have 7 by 2 and 9 by 2 and I have 7 into 2 and 9 into 2. Now you can see that in both these cases, the sign remains the same, right? 7 by 2 is 3.5 and 9 by 2 is 4.5 and 3.5 is less than 4.5. Over here you have 14 and over here you have 18 and 14 is less than 18, right? So that's why we can do these operations on these two quantities and maintain the relationship as it is. Now you will see very soon how this is a very important and very helpful way of solving QC questions. Now remember, you can multiply and only divide with positive numbers. What happens if you do this with negative numbers? Let's see that over here. If I multiply 7 with minus 2 and 9 with minus 2, I have minus 14 and minus 18. And minus 14 is greater than minus 18. So you can see that the sign is changing, right? Over here we had less than and over here we are having greater than. That's why we don't do this with negative numbers. And the same holds true if you divide by a negative number. Say 7 by minus 2 and 9 by minus 2, you can see that the sign is reversing. Alright, so we have seen the reason behind this. Now let's try to apply it to this question over here. Now quantity A is x minus 9x square minus 12 and quantity B is 15 plus x minus 9x square. You can see that over here you have an x and over here you have an x, right? So let's subtract x from quantity A and quantity B. Alright, so what is left in quantity A? That would be minus 9x square minus 12 and in quantity B you have 15 minus 9x square, right? Because this x and this x has been removed. Now over here you have a minus 9x square. Over here also you have a minus 9x square. So let's add 9x square to both the quantities. And what are you left with? Over here you have minus 12 and on quantity B you have 15, right? Now it is very easy to see that 15 is greater than minus 12. Therefore, the correct answer to this question is option B, that is quantity B is greater than quantity A. Now let's do one more question. Say this is the question given to you. Quantity A is x square minus 6x plus 12 and quantity B is 2. Alright, now we know that A minus B the whole square is equal to A square minus 2AB plus B square. So we are using a little bit of our algebra knowledge over here, right? Now over here you can see that you have x square minus 6x plus 12. That's the same thing as x square minus 2 into 3 into x plus 12, right? So this is very similar to what we have over here, right? Now if I can change this 12 to 3 square, then I could convert it into this form, right? So let's do that over here. I'm converting this to x square minus 2 into 3 into x plus 9. So I'm changing 12 to 9, right? For this I have to subtract quantity A by 3, right? Now let me do the same thing to quantity B also. So 2 minus 3 gives me minus 1 in quantity B. Alright, now quantity A is x square minus 6x plus 9, right? That is the same as x minus 3 the whole square, right? Now because we are squaring it, this will always be positive, right? Now over here you have a negative number in quantity B and quantity A is always positive. So definitely quantity A is greater than quantity B, and hence the correct answer to this question is option A. Alright, now let's see the next tool in our kit. So the first one was doing operations on the quantities. Alright, now the second one that we discuss over here is plugging in numbers. Let's discuss that over here with the sample question. Bob bought X chocolates for Y dollars. Alright, each chocolate has the same price. Now quantity A is X by Y and quantity B is 2. Now we need to find the relationship between these two quantities. So it's very convenient to plug in some numbers. Let's do that. What if X is equal to 2 and Y is equal to 1? X by Y is equal to 2 by 1, which is equal to 2, and quantity B is 2. So both of them are equal. What if I substitute X as 4 and Y as 4? In this case, X by Y is 4 by 4, which is equal to 1, and quantity B is 2, right? So in this case it was equal, and in this case quantity B is greater than quantity A. Therefore we cannot ascertain the relationship, right? Therefore the correct answer to this question is option D. Alright, now using this question, let's try to analyze this method in a better way. Alright, so let me make some space over here. Now a very useful thing about plugging in numbers is that quickly you narrow down to two options, right? For example, what do I mean with that? Now we substituted over here X is equal to 2 and Y is equal to 1, and we got that A is equal to B, right? We got the two quantities as equal. Now we have four options: A, B, C and D. So option A is straightly out, right? Because they are equal over here. Similarly, option B is also out. Now we are left with only two options, that is option C and option D. So plugging in numbers quickly narrows down your answer to two options. Alright, now what's the next thing? The next thing about plugging in numbers is it's very useful to prove the answer as option D. But this usefulness is also its drawback. Unless you get two contradictory situations, you cannot be certain that the answer is A, B or C, right? So sometimes you may get quantity A is greater than quantity B for some numbers when you plug it in. But if you are trying multiple ways and still you're not able to get a contradictory result, then you either have to guess and move forward, or you have to try to use algebra to be sure that that is the correct answer. Let's see what do we mean with that. So over here I have another question. Quantity A is 10x plus 4 and quantity B is 4x plus 10. Now if you substitute x is equal to 0, you get quantity A as 4 and quantity B as 10, right? So 4 is less than 10. Alright, now what if you substitute x as 1 by 2? Let's try that. In quantity A, you have 10 into 1 by 2, which is 5, 5 plus 4, which is 9. So you get 9 in quantity A, and in quantity B, you have 4 into 1 by 2, which is 1, which is 2, and 2 plus 10, which is 12. So again, you have 9 and 12, and the relationship is the same. Now, because you tried two numbers and you are getting the same relationship, you may be tempted to go ahead with answer option B, but that might not be the answer, right? That's the drawback over here. You can't be certain without two contradictory results. What do we mean with that? Let's proceed and try some more values for x. What if I substitute x is equal to minus 1? I get minus 6 as quantity A and 6 as quantity B. Again, the relationship is less than. Alright. But if I substitute x is equal to 1, what do I get? I get 10 plus 4, which is 14. And over here I have 4 plus 10, which is 14. In this case, the relationship is different, right? Therefore, the correct answer to this question is option D. It is not option B. That's why we need to be careful when using plugging in numbers. Alright, now let me quickly show you one more method with which you could have solved this question, which is the first technique that we discussed, which is performing operations on the quantities, right? Over here you have 10x plus 4 and you have 4x plus 10, right? If you subtract 4 from both, you get 10x and 4x plus 6, right? Now, after this, if you subtract 4x from both, you get 6x over here, and over here you get 6, right? Now, let's divide both the quantities by 6, which is a positive number. So you get x over here and you have 1 over here, right? So basically you're trying to compare x and 1, and there is no criteria given that x is positive or x is negative, nothing, right? So x could be minus 1, in which case you will have a relationship like this, and x could be 1000, in which case you have a relationship like this. So clearly the correct answer to this question is option D. Alright, now let's proceed and try to see what is a good range of numbers to try when you plug in numbers. So what type of numbers should you use? Now remember, a common trap that students fall into is trying numbers of the same type again and again. That would just give you the same result again, right? So you need to have a very good mix of numbers when you try plugging in numbers. Let's see that over here. So over here we have a number line. Now some of the good numbers to try in questions is minus 1, 0 and 1, right? So plugging in these are always good. Also try plugging in a proper fraction, which is something between 0 and 1. Let's say 1 by 2, and also take a negative fraction, which is, for example, minus 1 by 2. Now also try to plug in numbers which are in these regions, right? That is greater than 1 and less than minus 1. For example, 2 or 10, and less than minus 1 would be minus 2 or minus 10. Now this would be a very good range of numbers to plug in and check. Let me write them over here. 0, 1, minus 1, 1 by 2, minus 1 by 2. For example, you can also take 100, minus 100, 1000. These help to check extreme cases. Alright, now why is it important to take numbers between 1 and 0 and minus 1 and 0? That is in this range, right? Why is it important? Let's see a special property of a proper fraction and a negative fraction. Let's see that over here. Now, if you take numbers between minus 1 and 0, let x be something between minus 1 and 0, and if you raise that number to a positive integer, then the value that you get over here will be greater than x, right? Let's see that with an example. But what is actually happening is you are moving towards the right of the number line. Now, if you take a number between 0 and 1, let that be your y. And if you raise it to a positive integer, then you are moving to the left. That is, this number over here will be less than y. Remember, on the number line, as you go to the right, you get greater numbers. And on the number line, as you move to the left, you get lower or smaller numbers. Alright, now let's check this. Let's take, for example, 1 by 2. So 1 by 2 is a number between 0 and 1. So let's take y as 1 by 2. Now, if we raise 1 by 2 to 2, we get 1 by 4, right? 1 by 2, the whole square is 1 by 4. Now, you can see that 1 by 4 is less than 1 by 2, right? So, we have moved towards the left, all right? Now, what if we take a number between minus 1 and 0? Let's try that over here. Now, for example, let's take x as minus 1 by 2. If I raise minus 1 by 2 to 2, I get 1 by 4, right? And 1 by 4 is greater than minus 1 by 2. So we have moved to the right, right? And this is not only the case of even powers. What if I take minus 1 by 2 to the power 3? In that case, I get minus 1 by 8, and minus 1 by 8 is also greater than minus 1 by 2, right? So when you do this, you're moving towards the right on the number line. All right, now let me keep this aside and make some space over here. Now, what about numbers which are greater than 1 and less than minus 1? Let's take two numbers, 10 and minus 10. And let's see whether this property holds true. If I take 10 and square it, 10 square is equal to 100, right? But 100 is greater than 10, which is not the case over here, right? 1 by 4 was less than 1 by 2, right? So this property over here is not true for numbers greater than 1, right? Now, what about this property which we discussed over here? Let's take minus 10, all right? And let's square it. If you square minus 10, you will get 100, right? And 100 is greater than minus 10. If you cube minus 10, you will get minus 1000, and minus 1000 is less than minus 10. So sometimes you're getting a greater than sign over here, and sometimes you're getting a less than sign over here. All right. So over here, we have just seen through a demonstration how numbers on different parts of the number line behave differently. That's why it is very important when you plug in numbers to check and try a QC question, you always should try a good range of numbers. All right, now let's do one more question. The question reads, x is greater than 5, y is less than 30, x and y are not equal. So this is the question stem. Now quantity A is x divided by y and quantity B is y divided by x. All right, now remember the approach should be to try to disprove the answer options or to get the answer as D, right? To get different relationships between the two quantities. All right, so over here we have x, we have y, and quantity A is x by y and quantity B is y by x. Now let's take some numbers. If I take x as 6 and y as 10, is the condition satisfied? Yes, x is greater than 5 and y is less than 30, right? Now, what about quantity A and B? Quantity A is 6 by 10 and quantity B is 10 by 6. So clearly B is greater than A. All right, now let's try to create a scenario where this is not the case. All right, now that should be our aim, right? Now remember, when you got B as greater than A, directly you have eliminated half of the options. That is, it cannot be answer option A and it cannot be answer option C. All right, now let's plug in the values x as 6 and y as 3. If x is 6 and y is 3, quantity A is 6 by 3 and quantity B is 3 by 6. And you can see that x is greater than 5 and y is less than 30. So the conditions are also satisfied. Now in this case, B is less than A, right? B is just 1 by 2 and A is 2. So B is less than A, and therefore the correct answer to this question is option D. Now remember, you won't always get answer option D trying plugging in numbers. Now in that case, either you can try another approach, maybe algebra, or if you're short on time, do your guess and move on. All right, now let's do some more questions where we practice plugging in numbers. So over here we have a question. X is a positive integer, so that's the question stem. Now quantity A is 0.8 to the power x and quantity B is 1 by 4. All right, now when x is equal to 1, what is the relationship? We have 8 by 10 as quantity A and quantity B is 1 by 4. So A is greater than B, right? Now when x is equal to 2, what happens? That's 0.8 to the power 2 or 8 by 10 into 8 by 10. That's equal to 64 by 100, right? And quantity B is still 1 by 4. Now again over here also 64 by 100 is greater than 1 by 4. Remember 1 by 4 is nothing but 25 by 100 or 25%, right? So again quantity A is greater, but you can see that in when x was 1, right, this is 80%. 8 by 10 is nothing but 80 by 100, which is 80%, right? Now when x is equal to 2, we are getting 64%. You can see that it is reducing, right? So you can just imagine, take an extreme value. Say we take x as 10,000. What would be the value of quantity A? That would be 0.8 to the power 10,000, right? Which will be very close to 0, right? Therefore, in this case, quantity B will be greater, right? Therefore, the correct answer to this question is option D. All right. Now, we have discussed plugging in numbers. Now, let me also remind you that you cannot plug in numbers in all types of questions, right? This is a common mistake that a lot of students make. Now, over here, I have 4 sample questions. Let's not try to solve them, but let's just discuss whether you can employ the approach of plugging in numbers in these questions. All right. So the first question says x is not 0 and 7 by x plus 2 is equal to 1 by 3x. So this is the given equation. Now, can you plug in numbers over here? You cannot, right? Some students may say that let me try x is equal to 1, x is equal to 10, etc. Right? But you cannot plug in numbers over here because you have an equation over here. So x can only be a value which is satisfying this equation over here. Therefore, you cannot use plugging in numbers to solve this question. What about the next question? It's given that x is between -1 and 1 and quantity a is 1 by x square and quantity b is x square. Over here, yes, you can plug in numbers, but remember when you plug in numbers, x should be in the given range which is permissible. Alright, what about this question over here? You have a point over here which is 3, 0. You have a point on this line which is 4, 2 and you have one more point on the same line which is 5, x. Now quantity A is x and quantity B is 3, right? Now in this case you cannot plug in numbers, right? You have to find the value of x and then establish whether quantity A or B is greater, right? You cannot do it because the slope of this line is fixed, right? Okay, now what about this question over here? Now over here you can see that you have a square PQRS. Now you need to compare the two shaded areas. Over here in quantity A you have area of PSR and in quantity B you have the area of this semicircle, right? Now this is a circle with QR as diameter. Now in this case, yes, you can employ plugging in numbers. You can take the side of the square as say 10 or 4 and you can solve the question, right? Because over here there is no criteria based on which you can choose the number, right? Even if you take algebra, if you say the side of the square is x, you can still solve it, right? And find which is greater area, or if you want you can plug in a number and say x is 10 and find which of these areas is greater. So remember, you cannot plug in any number. When you plug in a number, it has to satisfy the criteria given, and you cannot always plug in numbers. If there is only some numbers which are allowed as per the question stem, then you cannot plug in any number. So this is a common mistake that students make. So that's why I'm highlighting it over here. All right, let's proceed. Now to make the method of plugging in numbers more effective, try to make the quantities equal. Let me show that to you over here. I have two quantities. Quantity A is 2x plus 3 and quantity B is 2x plus 3 the whole cube. Now when x is equal to minus 3 by 2, these two quantities become 0, right? Over here you have minus 3 plus 3, right? 2 into minus 3 by 2 is minus 3 plus 3 is 0, and over here also you have 0 to the power 3 which is 0. So these two are equal, right? Now clearly A, B, C and D, you are getting A and B out of the question. Now you are just left with two more options. Now try to plug in any other value. Let's say x is equal to 1. In that case, quantity A is 2 plus 3 which is 5 and quantity B is 5 to the power 3. And these are not equal, right? Don't waste time to calculate this. These are just not equal. So in one case you have both of the quantities equal and in another case you have them not equal. Therefore, the correct answer to this question is option D. Let's do a few more practice questions with this approach. All right. So over here I have a question. Quantity A is x square plus 3x cube minus 5 and quantity B is 3x to the power 5 minus 2x to the power 4 minus 5. All right. Now over here you can see that I have a constant term minus 5 and minus 5 in both the cases, and all the other terms have x. So if I substitute x is equal to 0, then quantity A becomes minus 5 and quantity B becomes minus 5, and these are equal, right? Now if I substitute any other value for x, let's try x is equal to 1. In this case, quantity A becomes 1 plus 3 minus 5 which is equal to minus 1, and quantity B becomes 3 minus 2 minus 5 which is equal to minus 4, right? And these two are not equal. Therefore, in one case you're getting the two quantities equal and in another case you're getting them as not equal, and hence the correct answer to this question is option D. Alright, what about the next question over here? I have quantity A as x plus 1 into x plus 2 into x plus 4 and quantity B as x minus 5 into x plus 20 into x plus 1. Alright, now you can see that you have x plus 1 in both the quantities, right, as a factor, right? Therefore, if I substitute x is equal to minus 1, then both the quantities become 0, right? Because 0 into anything is 0, right? Therefore, quantity A is 0 and quantity B also is 0, and these two become equal. Now, let me substitute any other value for x. Now, because I have x is equal to x minus 5 as a factor over here, if I substitute x is equal to 5, this factor over here will become 5 minus 5, which is equal to 0. So, let's try that. At x is equal to 5, you can see that quantity A is not 0, right? It's 6 into 7 into 9, right? You don't need to calculate it. It's just not 0. And quantity B is 0, right? So they are not equal, right? Again, the answer to this question is option D. So this is a very interesting approach. When you plug in numbers, try whether you can make the two quantities equal. And if you can do that, then try another combination and see whether they are still equal or not. Alright, now we have discussed two methods. One is performing operations on the quantities, and the second method that we discussed is plugging in numbers. Let's proceed. Another important thing to keep in mind when you do QC questions is to spend time with the question stem if there is a question stem. So always remember, slow down at the beginning when you do a QC question and spend time with the question stem. Read the question carefully, and if you feel that the answer is obvious, always beware, there might be a trap. Alright, now let's see a sample question over here. A is an integer and not odd, and statement A or quantity A is number of different prime factors of A, and quantity B is number of different prime factors of 2A to the power 2. Alright, now over here in the question stem it's mentioned that A is an integer, alright, and it's not odd. So definitely A has to be even, right? Okay, now let's take a few even sample numbers. I have minus 10, 0, 10. Alright, now let's try minus 10. If I take minus 10 as quantity A, then quantity B will be 2 into minus 10, which is minus 20 to the power 2. Alright, now what are the prime factors of minus 10? And remember, over here we are checking for different prime factors. Alright, now minus 10 is minus 1 into 2 into 5. Therefore, there are two prime factors for minus 10, right? Now, remember, minus 1 is not a prime number. Alright, now over here, 2A to the power 2 will be minus 20 square, which is equal to 400. Now, let's prime factorize 400. That would be 2 to the power 4 into 5 square, right? Now, again, you have just two prime factors which are different, right? You have 2 and 5, right? So, these two are the same, and hence the correct answer to this question is option C. Now remember, logically also you can solve this. Over here it's given that A is even, right? So this over here is definitely even, and over here we are just multiplying with 2, right? And then squaring. Squaring a number will not give it a different prime factor, right? So because you are just multiplying with 2, and to start with A was even already, therefore we are not adding a new prime factor to it, and hence quantity A and quantity B are equal. Now, let's proceed to the next important technique for our arsenal, which is approximation. Always try to minimize the calculation to solve QC questions. Try to compare instead of solving. What do I mean with that? Let's take a few examples. Quantity A over here is the circumference of a circle with radius 4, and quantity B is 24. Alright, now we know that the circumference is 2 pi r, right? Now over here the radius is 4. So that would be 2 pi into 4. That would be quantity A. Now you could take the value of pi as 3.14 and find the exact value for quantity A, but that's not the best method, right? We know that pi is 3.14, so it's something greater than 3, right? Therefore, you're just multiplying 2 with something greater than 3 and 4. So that would be a value greater than 24, right? Now over here you have 24. And over here you have a value greater than 24. Definitely quantity A will be greater, and that is the correct answer. So we have saved time, right? You can see that you can do this mentally. You don't even need to use the calculator provided to you. Alright, so remember to compare instead of solving. Don't try to find the exact answer. We just need to know which quantity is greater. Let's do one more question. So over here, quantity A is 23.3 plus 72.5 plus 98.34. Quantity B is 73.86 plus 24.84 plus 98.5. Now, you could take your calculator and find these two sums and establish which quantity is greater, but that is not the best approach, right? If you look carefully at this question, you can see that if you compare 23.3 and 24.84, 24.84 is the bigger number, right? Now, if you compare 72.5 and 73.86, this one over here is the bigger number, right? Now, again, if you compare 98.34 and 98.5, 98.5 is the bigger number. So by comparing these three numbers individually, it's bigger on this side, right? Therefore, definitely quantity B has to be greater than quantity A, and the correct answer to this question is option B. Now, if you do it in this approach, you can do this question much faster than by finding the exact answer of quantity A and quantity B, right? So try to compare instead of solving. Let's do one more question. Quantity A is 23.3 by 45 and quantity B is 419 by 850. Alright, now over here 23.3 by 46. What can you observe? If the denominator was 46.6, that is twice 23.3, this fraction would be 1 by 2, right? 23.3 into 2 is 46.6. That's why I've taken 46.6 in the denominator. Now this ratio is 1 by 2. Now over here you can see that the denominator is slightly less than 46.6, right? Therefore, this fraction over here will be more than 1 by 2, right? Now what about quantity B? It's 419 by 850. Now 2 times 419 is 838. So if the fraction was 419 by 838, the fraction would be equivalent to 1 by 2. Now the denominator over here is slightly greater than 838, right? Therefore, this fraction over here will be less than 1 by 2. So quantity A is greater than 1 by 2 and quantity B is less than 1 by 2, and therefore the answer to this question is option A, that is quantity A is the greater number. Let's do one more question. Quantity A is 2308 into 6048 and quantity B is 4598 into 2987. Now you could take your calculator and do this multiplication and find which quantity is greater, right? But there is a better approach, right? Over here you can see that 2308 is a bit greater than 2300 and 6048 is a bit greater than 6000. So let me write that over here. Now what about quantity B? This is 4598. This is 2987. So 4598 is a bit less than 4600 and 2987 is a bit less than 3000, right? So let me write that over here. Now we are just comparing these two, right? Now I can multiply this part over here with 2 and divide this part with 1 by 2, right? It does not change the answer because 2 into 1 by 2 is 1. Now 2300 becomes 4600. Now because this is a little bit greater than 2300, this becomes greater than 4600, and similarly this part becomes greater than 3000. So quantity A is a number greater than 4600 into a number greater than 3000, and quantity B is a number less than 4600 multiplied with a number less than 3000. Now definitely quantity A has to be greater because these two are greater, right? Therefore the correct answer to this question is option A. Now let me quickly summarize what are the 4 techniques that we have discussed over here. Try to perform operations on the quantities and simplify the quantities so that you can easily establish which quantity is greater. Now plugging in numbers is a very useful technique. It directly eliminates 2 options, but the disadvantage of plugging in numbers is you cannot be certain unless you get 2 contradictory scenarios. Now again we discussed an easy method where trying to make the quantities equal helps you plug in numbers in an effective manner. And remember, if you have a question stem, spend time with the question stem and slow down. Don't rush and make a silly mistake. And the fourth technique that we discussed is try to compare instead of solve. That will save you a lot of crucial time. Now, before we end this video, let's quickly have some tips and traps about QC questions. The first thing is, think if you can reduce calculations and use logic. Let's take an example. I have quantity A as minus 15 into 23 into minus 72 into minus 83. Quantity B is 29 into minus 43 into 68 into minus 197. Now, if you take your calculator and do this calculation, it will waste a lot of your time, right? Try to use logic. You can see that quantity A has 1, 2, 3, three negative signs. Therefore, quantity A will be negative and quantity B has only two negative signs. Therefore, quantity B will be positive, right? Therefore, using logic, even without doing any calculation, you can establish that quantity B is greater than quantity A. All right. Now, the second thing that I want to remind you is plug in numbers only where you can, right? We have seen scenarios where you cannot plug in numbers. For example, if you have a question 2x plus 4y is equal to 8 and minus x plus 6y is equal to 14. This is the question stem and quantity A is y and quantity B is 3, right? Remember, you cannot plug in numbers over here. You'll have to solve and find the value of y and then check whether it is greater than or less than 3. Now, the next point is geometric figures are not necessarily drawn to scale. Now, over here you have a figure. This looks like a square, but don't assume that it is a square unless it is mentioned. And lastly, remember, always spend time with the question stem. You can always draw out inferences which is not very obvious if you spend time with the question stem.